So I'm excited to be here. Last time I was at RailsConf was Phoenix 2017. At that time, I was an editor for the newsletter called This Week in Rails, which is still happening. If you are not a subscriber and you're interested, there's weekly updates about Ruby on Rails. We were all able to get together in person, the folks that were there. The objectives of this talk are to review 5 types of database scaling challenges and solutions, and hopefully for you to consider integrating the tools and techniques presented into your applications. So hopefully there's something new here for everyone. The topics are safe migrations on large, busy databases, maximizing performance of database connections, maintaining fast SQL queries, high-impact database maintenance, and implementing replication and partitioning. I work for Fountain, which is a high-volume hiring platform. We're here at RailsConf, we're a sponsor, so come and check out our booth. A bunch of other Fountain engineers are up here in the front. Thank you for coming. We're a remote-first company. You can check out our openings at fountain.com/careers. A little bit about me, I'm a staff software engineer at Fountain. I mostly work with Rails, Postgres, and Elasticsearch. And I'm also a dad of 2, got a couple of young kids. So in my house, we talk about Paw Patrol a lot, and you're gonna hear about Paw Patrol today. For parents, you probably understand where I'm coming from. For people that don't have kids, you're probably like, what is he doing? But Paw Patrol has been around for a long time in cartoon form, and last fall they made a feature-length movie, and the title of the movie was called The Movie. And I saw it with my daughters. It was a lot of fun, and when I had the opportunity to do this presentation, I thought it would be fun to have a theme and a story and some characters. So I looked around my house for inspiration, and I found Paw Patrol on the cereal box, on the home stereo, on the floor. Daughters were playing with toys, dressing up as characters. So I would like to pitch you today on Paw Patrol 2, the sequel. Yes. Okay, so the plot is that it's set 5 years later after the movie, and evil Mayor Humdinger is gone, so the pups are safe. He was abducting pups in the movie. Rescues are down, though, so the Paw Patrol, frankly, they have a lot more time on their hands, so they've pivoted into startups, and they built an app called Pup Tracker to track pups, tracks their geolocation primarily, it keeps them safe, and they've scaled their app. They, of course, built it with Ruby on Rails and Postgres, and it's used around the world now. They ran into scaling challenges, and today we're gonna learn about we're gonna hear from 5 pups about their challenges and solutions. So the pups are Liberty, Marshall, Chase, Rubble, and Sky. We're gonna hear from Liberty first. So she's the newest Paw Patrol member. She's eager to make an impact. She did a lot of product development, and she wrote a lot of database migrations. Whoops, okay. So Liberty's gonna discuss migrations on large, busy tables. So as tables grew to millions of rows, making structure changes could take a long time and cause application errors. Let's look at an example. So an example would be a check constraint. If you're not familiar with check constraints, it's sort of like Rails active record model validations, but in the database. So in this case, we're going to introduce a migration on the pups table on the birth date column, ensuring that the birth date is newer than 1990. I kind of thought, what is the oldest a dog could be? And I think the record was like 27 years or something. So anyway, I picked this date intentionally. And what can happen when you add a check constraint is it's going to check all of the rows in the table. If the table is hundreds of millions of rows, it's going to take a long time. And adding a check constraint blocks reads and writes to that table. And this is from the strong migrations gem, which I'm going to talk about a lot. So what can we do to avoid that problem? We don't want to block reads and writes. Those queries are going to time out. They're going to cause application errors. What we can do is we can add the constraint, but not validate existing rows. And we can do that with that same migration, but we can add validate false at the end. And so this check constraint will be in place for new rows being inserted or being updated into the database, but the existing rows will not have yet been checked. So we want another migration to validate those rows. And so what we did was take one migration and break it into 2, more or less. And this validation phase takes a less disruptive lock when it runs. So it's still recommended to run perhaps off-peak time when you have lower traffic, or potentially in downtime if you're, for a very large table and you have concerns and you're not able to test this on a test database. But it is less disruptive than adding the constraint without this approach. Let's look at one more example for big tables. This one has a few things packed into it. So in this one, a column is being added, and when we add a column, it briefly takes an exclusive lock on the table to change the structure of the table. But when we add a nullable column, it's a very short-lived lock. But what's happening here is within this transaction, we're updating all of the location rows. And if you imagine the location rows are all of those geolocations from the pups, let's say there's tens of millions of rows in the table, then that lock is going to be in place for the duration of that backfill, which is essentially going to take down your application. You don't want that. So strong migrations, again, it's a gem. If you're not familiar with it, it works with Postgres or MySQL. It lists out a lot of potentially unsafe migrations, and it provides safe variations, so it's very helpful. And it has this guidance, 3 keys to backfilling safely: batching, throttling, and running it outside a transaction. So let's look at that. So first we're gonna break that original migration into 2. We'll create one first that just adds the column, it's nullable, and then once we deploy this migration, we have this column in place, the application can set the value, can set a city ID, but the old rows will still be null. So we're gonna create a second migration, and we're gonna disable transactions with that disable DDL transaction. Perhaps you've used that before. Otherwise, all of the migrations run within a transaction, and if something fails, that transaction will be rolled back. So we're gonna say, don't run this in a transaction because we want at least partial success. We don't wanna roll back the transaction. And then instead of trying to update all of the location rows at once, we're gonna update batches of the location rows. And we can also throttle this with sleep. And so this would be safe to do, and it would update batches of rows at a time so that all of the rows then had that data in place for that new column. So some good practices. There's a lot more than this. These are just 2 I chose that may be things you might run into. Liberty studied potentially unsafe migrations from the strong migrations gem and used safe variations, and generally took the approach of trying to modify new rows as a separate operation from modifying existing rows. So next section, Marshall. Marshall's the fire pup. He's an emergency responder. He extinguishes literal fires, actual fires, and database fires. It's pretty cool. So Marshall learned about database connections, which are a limited resource. Connections are used anytime the application or background workers do any sort of interaction with the database server. Marshall observed in the pup tracker app, connections were used by Puma, were used by Sidekick workers. We do have the active record connection pool that lets us set some limits, so we can set a safe limit, and we can do some math to figure out how many workers we have, if they're multi-threaded, how many concurrent database connections we might have per worker process or per application server process. So you might have something like this, where you have, let's say, 4 application server processes with direct connections to the database. You might have 2 background worker processes with direct connections. You might have configuration like this with a connection pool of 5 and Sidekick's concurrency configured at 5. These numbers aren't very important, they're just examples. And there's some resource consumption and, on the database server per connection. So Postgres forks the main postmaster process when Postgres starts. That process is forked for every new client connection coming in. So every select, insert, update, every statement going to the database. And there's some overhead associated with that, and it's going to use some of the memory that's available for client connections from the database server. And there's also other things using the memory too. So if you say you've got a 100 gigabyte database server, there's also background processes running like auto vacuum. There's also idle connections that will be using memory that may not be actively serving any requests. So Marshall has a couple of options for scaling. More or less, Marshall needs more memory to do more connections to serve more traffic. So he could scale the database server vertically and he would get more memory, perhaps bumping up an instance class if you're running on AWS RDS, for example. And then option 2 would be to try to use the available connections more efficiently if that's possible. Turns out that is possible. There's something called database connection pooling. Connection poolers it's an additional piece of software you would run within your application stack, and is dedicated to the efficient usage of connections. And there's open source options, commercial options, and the connection pooler doesn't replace the active record connection pool. I know I was kind of confused about that when I was learning about this. It runs in addition to that, so you can have application-side connection pooling, and then you can have an infrastructure connection pooler. And among other things, a connection pooler eliminates that overhead of establishing new connections per client request. Poolers also offer additional features like modes, where you can be more conservative or more aggressive with how those connections are reused across transactions and even statements. So this was what we had before, and then with the connection pooler, the app server processes now connect to the pooler, the background worker processes connect to the pooler connects to the Postgres database. So Marshall implemented connection pooling. This is an example from PG Bouncer. Marshall installed PG Bouncer for PubTracker, and this is an example from the configuration and it's actually quite easy to set up if you want to set it up locally. In production, it's a bigger deal, but if you want to play around with it locally, you can run it. It runs on a different port from Postgres. Your application connects to that port, and more or less it works. You configure the bouncer to connect to the database server. So connection pooling was introduced for PubTracker and improved performance without the need to scale the database server vertically. So let's look at fast SQL queries with Chase. Chase is another emergency responder, and he's got this cool race like police car with a motorcycle in the middle that shoots out of the middle. It's pretty neat. So Chase investigates slow queries. Let's look at a query. Select star from locations where ID equals 1. So we're asking for one row from the locations table. If you're not used to looking at query plans, we're going to look at one. Prepare yourself. It's a big wall of text. You can use explain, and then explain has options like analyze, buffers. Explain is useful on its own. Analyze will actually execute the query and give you a lot more information. It'll give you information about how long it ran. So what I've done here is I created a locations table and put 10 million rows into it. And it doesn't have a primary key on it, so it doesn't have a primary key constraint or an index for that primary key constraint. And looking up one row on my laptop, it took around 330 milliseconds, which is long-ish for a query. And if you read query plans, you want to start from the bottom and read towards the top. And the aspects of the query plan are called nodes. So we can see that a parallel SEQ scan or sequential scan was used here. So a sequential scan is a table scan, and that means Postgres doesn't know how to get this row in an efficient way. It just needs to go through the entire table to find the row that it needs. So what if there was a way we could do that more efficiently? Well, there is. It's called indexes, which you may be familiar with. And typically when you set up a primary key constraint on a column, or typically in Rails, we do have ID primary keys, and then we would have an index for that primary key constraint. So what I did was just modify this locations table to have that. So alter table locations, add primary key, and then in PSQL, we can do \d locations, look at the table, and we'll see that it has this index now. That's in this first box, just to show you the index is there. And then I just did another explain analyze with that same query again, and we can now see if we read from the bottom, it's only taking 0.1 milliseconds, much faster, and it's using an index scan instead of a parallel sequential scan. We can see the name of the index it's using and some additional data about the estimates the query planner came up with. So Chase would like to repeat this process for all the queries running for PubTracker, and Chase enables an extension called PG-stat statements, which ships with Postgres. If you haven't seen it before, it's something that you can enable on your database, and the cloud provided databases generally support it as well. And it does a query normalization process where it removes the specific arguments to the query. So for example, it's removed 1 from ID equals 1. Now we just have ID equals question mark. And that means what we can do is count all of those up. So if we have 3 of those where it might be ID 1, 2, and 3, that'll be 3 tallies of this type of query. And now we know the total calls, we can look at the average time, and we can do statistics on the queries. So why would you want to do that? Well, you want to, running an application, there's a lot of queries all the time. You want to focus on the highest value queries that caused the most resource usage and focus your optimization efforts on those. So taking a statistics-based approach is helpful. You can actually look at this data directly in the PG stat statements. There's a system catalog view that you can look at and see the query results, but I found this PG Hero tool to be even more helpful. It takes the PG stat statement statistical data and presents it in a nice web UI. It's also an open source project. It's a Ruby-based and Rails-based application that you can also contribute to if you're interested. So it's a performance dashboard for Postgres. It shows, besides slow queries, unused and invalid indexes, high connections, a bunch of other useful info. So Chase develops a query investigation process. He can get the query plan via explain. He can make database changes like add an index. Or in some cases, he might want to use the gem marginalia, which is now part of Rails 7, by default to actually go back to the application from the SQL query and see where it originated from. So in this case, we can see a comment on every SQL query with marginalia. We can see it came from the locations controller and the index action. And at that point, then Chase can determine, could I make this query more selective? Maybe adding a named scope. Maybe it's selecting more rows than it needs to. Maybe it makes sense to just rewrite the query. That's sometimes the outcome. So Chase works to improve query performance. Besides looking at the queries, he also wants to make sure Analyze has run recently for the tables where there are slow queries. Analyze collects table statistics, column statistics, and those statistics are used by the query planner. So this would be done outside of Rails. It would be from, for example, a PSQL session to the database. Chase can also add missing indexes. When he sees sequential scans, it's likely that there's an opportunity to add an index for that field. He can also rebuild indexes. So there's a term called bloat you may have seen, and that more or less means fragmented data over time on tables that are heavily updated. Indexes for those tables can become fragmented or bloated, and it's helpful to rebuild the indexes to ensure that they're optimal for the queries as well. So sometimes it doesn't make sense to focus on the query plan. It makes more sense to focus on the table statistics, the indexes. And then when it does make sense to focus on the query plan, Chase can use tools like PG Mustard and PG Analyze. All of these tools are linked in the presentation, by the way, so if you want to download this later, they're all linked up. Rubble's going to talk about database maintenance. Got about 11 minutes, so I'm going to blast through maintenance. Maintenance, vacuum, auto vacuum, analyze, rebuilding bloated indexes we just talked about, removing unused indexes. So vacuum, the Postgres documentation refers to it as the garbage collection process for Postgres. And I think that's a good definition with a short amount of time. More or less it's running. You can think of auto vacuum as running, and it's generally considered to be very conservative because Postgres can run on very small hardware. So as your workload increases, it's very common to increase the resources available to auto vacuum and make it run more aggressively. So that means it runs more frequently, and you balance that with not being too disruptive to the actual application queries running on the database. And yes, we also covered bloated indexes, so unused indexes. Postgres helpfully tracks scans. Every time an index scan occurs in a query plan, Postgres makes a little check mark in its system catalogs. And that's helpful because then we can find indexes that actually have never been used as part of a query plan. And in those cases, generally, you want to remove those. So Rubble uses reindex to rebuild the bloated indexes. In Postgres 12 and newer, we can do that concurrently. So we can do that manually. In earlier versions of Postgres, you can use PG repack to achieve a similar outcome. We can also automate that and do that periodically with the PG cron extension. And Rubble sets up PG cron to run maintenance tasks periodically. This example is showing a manual vacuum on the locations table, that locations table that's getting all the writes. So we have a cron schedule, and then we have the database command to run, and you can set this up for any database tasks. So quick recap on maintenance. Rubble made sure vacuum and analyze ran regularly. He removed unused indexes, and he automated some maintenance tasks. Okay, last pup, Sky. She's got a helicopter. She's responsible for aerial response. And so she takes in the big picture. She's going to talk to us about multiple databases and replication and partitioning in 9 minutes. Okay, so write and read workloads. Reads are all of your selects. Writes are everything else, more or less, inserts, updates, and deletes. PubTracker had 10 times more reads than writes, and generally that's the case for web applications. A row is inserted, that row is read many, many times by many clients. And writes and reads are generally, they're all occurring on one database unless you run them on multiple databases. So the resource usage for those queries could be separated. That's what Sky wanted to do for PubTracker. So Sky set up a read replica. This is done outside of Rails. If you're on RDS, on AWS, for example, I have more experience with that. It's pretty straightforward to create a replica database. There's a bunch of options for how you want that replication to occur. Generally, the category is called streaming replication, and you would set that up, and then the application needs to be configured to address both of that primary and the replica, and we'll take a look at that. And since Rails 6, we have multiple databases supported natively with Rails. So your YAML config might go from 2-tier to 3-tier, and we're gonna call the primary, primary, and the replica, replica, because those names are straightforward. And the replica needs this additional config called replica true, and that tells Rails not to run migrations against that replica, and it does some other things. We also need to configure the base class that we inherit from for active record models to wire up the primary and the replica, and that would be in the application record class. So we're gonna set the reading role, and now once we've done that, we can actually manually relocate queries to the read replica. So we have this Ruby block, and we can say connect to the reading role, and we could do a query like finding 5 locations for Sky, for example. And Rails actually lets us do this automatically as well. We can, for get and head requests, they're only gonna need read access to the data, so those requests can take advantage of automatic role switching if you wanna automatically send those requests to the replica. Okay, last section, partitioning, we're almost there. 7 minutes, doing pretty well. Okay, so we've got all these geolocations from the pups. The table's enormous. Things start to happen that you don't see when the table sizes are smaller, when you get into the tens of millions, hundreds of millions, or even billions of rows. So queries have slowed down. Vacuum takes forever to run. And interestingly, the application only looks at the last month of locations, but we have years worth of locations in the database. So what we can do is, Sky investigates this problem. What do people do in this, with these inputs? And she finds Postgres' native table partitioning, which is available since Postgres 10. There's a number of partitioning types, but she selects range partitioning and the created at column as a partition key. And she wants to create monthly partitions. So we're gonna take that original unpartitioned table and slice it up into month chunks. What are some of the benefits to doing that? Partitions that are no longer, the biggest one is partitions that are no longer reachable from the application can be detached or removed from the database, which I'll discuss further. Partitioning also greatly reduces the quantity of the data needed in the database. Then it maps up more to what the application's using. And as a result of the smaller partitions, indexes on those partitions are smaller. Scanning those whole partitions is faster, and maintenance can actually run in parallel across partitions as opposed to one worker per table. What are the challenges to implementing partitioning? It is a migration from an unpartitioned table to a partitioned table, and it does either require a bit of downtime or it requires a double writing strategy. You can use database triggers to achieve that, but it is more work. And you do need to test queries on partitioned tables before rollout. You don't want to make queries perform worse by scanning multiple partitions. And there's more operational complexity. You actually need to create the partitions in advance of when you would write to them. So you have a dependency now on a process that does that. But Sky implements partitioning for PubTracker. She uses pgslice, which is another Ruby gem. It helps generate SQL commands to take an unpartitioned table to a partitioned table, and she's able to schedule that with pgcron. Okay, so in the interest of time, I'm gonna skip this, but this is a couple of the commands for partitioning. There are about 4 or 5 commands setting up the partition table and moving the data over to a replacement table and an intermediate table to help you with the transition. And then you can also detach the partition later. So for our old locations we don't need anymore, we can detach concurrently, and then it's a regular Postgres table that could be You could use pgdump to archive it. You could just drop the partition if you didn't need the data any longer. Okay, so summaries. Use safe migrations. Liberty used safe migrations suggested by strong migrations. Liberty separated her database changes into 2 phases, modifying new rows and then modifying existing rows. Marshall used a connection pooler. He learned that database connections are costly, they're a finite resource, they use memory on the database server, and he implemented a connection pooler to improve performance and scalability for pup tracker. Chase found and fixed slow queries. He set up PGHero as a performance dashboard for the whole team, set up query statistics to spend query optimization efforts most efficiently, and Chase worked to improve queries, sometimes rewriting them. Rubble performed database maintenance. He monitored vacuum and analyze. He performed manual index rebuilds and sometimes scheduled those. And Sky looked at replication and partitioning. Sky configured multiple databases. Sky used the read replica to direct read queries to the replica, and Sky implemented range partitioning for that big locations table to be able to cycle out old data and improve performance for queries on that table. So a special thank you to all of these folks. So Twitter handles, they helped me with reviews of this talk. I really appreciate it. I think it helped to really focus the content down. And thanks, that's all I've got for you. I'll be tweeting this out. Hashtag link, closing slide with a 1-slide summary of everything I talked about. Thank you. Any questions, especially if they're about Paw Patrol characters? Yeah, I probably wouldn't use a migration for it, but the question was about why wouldn't you backfill data with a script, maybe like a rake task, maybe it runs in a one-off job or something. That's typically how most organizations do it where I have worked, is they would use a script to backfill data. I guess the intention there was to show the connection to a transaction and backfill, and then actually taking a longer lock that would be fine otherwise, but how the relationship of a long-running backfill would actually extend that lock period. I think it was kind of it's a little bit of a contrived example. That being said, I do think that if you're newer to Rails and databases, you may do a backfill and a migration. Like it's a reasonable idea, but I think I would likely suggest, like if I was reviewing that PR, I would say, I would suggest that we move that to like a task that we run offline, do some testing with it. Yeah, question was about what's like a rule of thumb or a heuristic about when to adopt partitioning, when is the pain worth it, the transition, the migration effort, and then what was the second part again?
Yeah, that's the same.
Okay, yeah, it's if you look in the Postgres docs, it just says at 100 million rows implement partitioning. No, I'm just kidding. It does not. I think it depends. I've asked, at where I work, we have a dedicated database administrator with decades of experience, and we've had a similar discussion. I think I think where we have implemented partitioning is for really high write tables, again, where we don't really need access to the data for a long period of time, and but we do want to retain the data and eventually export it. That's a specific place where we've implemented range partitioning. And then another place where we're looking at list partitioning is for one of our most heavily written and queried tables, where we can break up the data by a tenant or an external account ID, and that allows us to improve some performance of queries, and also, again, the maintenance benefits and that sort of thing. So I'd suggest generally looking at your largest and busiest tables as a starting point, and then, but you're probably, I don't know that it would be worth the investment until you get into the tens or hundreds of millions of rows. Sure. All right, well, we're at 11:05. I think we'll wrap it up. Thanks again for coming, everyone. Yeah.